Yeah, so we use delegation to build a very simple table view app. We'll see the table view again today. We'll mostly use it in a very similar way how we used it last week. We'll add one little twist, and then it'll come up again. We'll keep adding to it bit by bit. Yeah, so we saw the data. We saw the table view. We saw delegation and action. So we had kind of made this contrived little example app where we created our own button. So we saw delegation for the first time there. And then, we saw it in a view component that Apple has created. And yeah, so again, it's used so we can know very little about, so the view can talk to a view controller and know very little about the view controller itself. So it makes for reusable components, and also makes it a little bit more clear. It separates tasks very clearly. So the view only notifies the delegate that something happened, and the view controller is in charge of actually performing the work and handling that situation. So it helps us separate responsibilities between the view and the view controller. So yeah, delegation we saw. Great. Yeah. So table view, delegation. What else did we do last week? We did something with functions. Does anyone remember? We passed functions as arguments into other functions. Very good. We'll see that again today. So very common. Who remembers use cases for passing functions as arguments into other functions? So we saw a couple of use cases. Who remembers one of them? Why would you need this? Why would you need to pass a function? And even if you don't remember what we did last week with this, yes? Say it again? So we weren't using it for errors necessarily, but yeah. So you could potentially use it also to create error reporting. I could see that. We didn't see it for that, but I could see they're used as well. Yeah. So something happens, and we want to maybe do something when an error happens. We could do that by passing in a function. Yes.
Duplicate code.
Duplicate code in what way?
Let's say function A prints a photo, and function B has the name of photo. So rather than having that also print out the photo, you can reference object A.
That's a good use case potentially. Yes, yeah. We didn't see that particular, but I could see that being a good idea. Yeah, cool. So we saw in class we saw one also 2 weeks ago. We did something. We wanted to delay an action. Do you guys remember that? Yeah. So we passed a function into the timer. And we wanted it to execute at a later time. So delayed execution is a great way to use functions as arguments into other functions. And then another way of delayed execution, I guess, is very often you see it when you're making web requests. So you don't want to block the UI with something. So you make a web request. It happens on another thread, not on the main thread. And then when the web response comes back, then you want to do something. So it's also a delayed response to something. Yeah, so web requests, very, very frequently you see functions as arguments as functions. And then, so another thing we saw was something very computationally heavy. We didn't want to do on the UI thread. We made a little fake computation that took a long time. We shifted that to a background thread, and then the result we then processed on the main thread again. So for UI work, you also see functions as parameters for other functions. You see that there as well. Great. Yeah, so that's what we did last week. Any questions about what we've done last week? We'll see a lot of the topics we'll see again today with little twists on it, and just to make sure that it sinks in. So pretty much, yeah, both concepts that we saw last week are pretty fundamental to working in any kind of environment where you have a UI and you like a phone. You see lots of phone apps. You see this computer apps for the Mac. You see delegation and function as parameters for functions as well there. So yeah, we want to make sure that we really understand what's going on there. Great. So let's start with just a little bit more of an exploration of the very last thing we saw last week. So let's start with a new playground. And I wanted to show you another cool use case for functions as parameters for other functions. This one is a little bit of a mind twist, or at least it was for me when I first saw it. But it's really useful for lots of things. So let's just create. We've been working with a student object. That's a very simple little object that we can work with. Let's create another student object. Oh, and I think I've gotten the feedback before that the dark mode is difficult to see. So let me just change that real quick. I apologize that I didn't do that in advance. Is that better to see? Better to see? Yeah, great. Okay. So let's create a student. And very simple, just let's create two properties, name, and let's do age. Let's do an int just for simplicity here. Great. So let's create an array of students. So and once we create the array of students, we're going to do a couple of cool things with it. So, so student, I think last week I had myself. So Axel, I am 33. Student, who wants to volunteer? Shout a name. Doesn't have to be yours. Create another. Yeah. Bob. Okay, let's do Bob. How old is Bob? Maybe Bob is. Let's make him 40. Maybe. Oh. Let's do Alicia, and let's make her 29. Okay, cool. So we have 3 students here. Oh, I'm missing a comma. And let's do a couple of cool things with it. So the first thing we saw yesterday, we saw, or last week, we saw a cool way to process each element in the student array, process it, and turn it into a new array with those processed. We processed each element of the array and create a new array out of that. So I think what we did last week was we created a display string for each of these students, and we did it with by iterating over each element of the array. Let's just quickly redo what we did last week. So the way that you've probably seen this before, so you would create let's say we want to or let's say we want to just we want to get all of the ages of the student. Let's get all of the ages, and then let's create and let's get only the age, and then let's sort those ages by smallest to largest. How would you do this? Let's start with just getting an array of ages for each of the students. How would you go about this?
I would use map function.
So the map function we want to use as the more advanced version. Let's hold off with the map function. So how would you do it without? So if you don't, so I'm assuming a lot of you have not seen the map function. We saw it very quickly last week. How would you create an array just of the age of each of these students? Let's create a loop, and we'll have an accumulator that holds all of the ages. Okay, so var ages an array of integers. And now we're going to iterate over the students for student in students. So there's this neat way that we've seen now a couple of times of iterating over an array where the last part is the array, and then we have this temporary variable that takes on each element of the array. So now for each iteration, we're adding an age to the ages here. So ages dot append student dot age. What did I do? Student. Oh. What am I doing wrong here? Student dot.
Is that study?
Say it again.
Is that ND for the dean student?
Thank you. Dot age. Thank you. That would have taken me a while. So let's just see what we got here. So let's just print the array. Oh, autocomplete is behaving funny today. Let's print the ages, and let's see what we get here. Okay, so yeah, we did the task. We had this accumulating array, and then we looped over each of them in this for loop, and now we can print it out. So, and then what we saw last week, we saw a way to do this in one line of code. And the concept here is we're going to do something with the array of students. So there's a function on this array. So arrays in Swift have functions associated. There's behavior that we can call on the array, which is very useful. So there's all this. There's all this processing power that is built into the array already. So we don't have to use utility functions where we have to know where they exist. It just exists on the array itself. So there's a function on the array that will take each array element, do something with it, and then just spit back the processed array. So that there is a functionality in this already built into the array that does that for us. So it's not just Swift that has this. It's common in other languages as well. So it's the map function. So what the map function does, and let's maybe so we did go pretty quickly last week. So let's see what the doesn't want us to. Okay, today. Maybe because I didn't autocomplete. Okay, it doesn't let us go to the definition of the map function. So let's just describe that. We can also do it without actually going there. So the map function takes as an argument a transformation function. So that the function takes another function as an argument. And this transformation function, if we're looking at the signature that it takes here, so ignore the throws. We have, so this is the signature of an anonymous function that takes a student as a parameter and returns another type. So we have a transformation function that takes a student object and turns it into any kind of other type. So this transformation function with map will call this transformation function for each of the elements, and then map will return a new array with the transformed elements. So it's very useful and slightly, it took a while for me to wrap my head around it, but once you've seen these kind of transformation functions a couple of times, it's fairly simple to see what it does. So map will return an array. So let's save this array as a new array. So let's call it mapped students, student ages. So we want map to return an array of integers. So this transformation function, what should it return? What should be the return type of this transformation function? So it'll take each element in the array and turn it into It'll turn it into, so yeah, the transformation function will turn a student into an integer. So I think the way we saw it last time might have been a little bit confusing, where we had it all as an anonymous function here. So let's just do it the long way. So we're going to create. So we're going to define a transformation function. So so we'll call it student to age transformation. So we're going to have a student to age transformation function. So it'll turns a student into an age, so it'll return an integer. And to be able to turn something into an integer, we need a student object that we pass into this function. So okay, so we now have a transformation function that takes a student as an argument and returns an integer. So this should not be, hopefully this is not a new concept to you, where we have a function where you pass in an argument and it returns it returns a result. So hopefully nothing new here. So how do we turn a student into its age? We take we return the age is a property on the student. So student dot age. So this is it. We have now a transformation function that takes a student and turns it into an age. And yeah, so map wants us to do exactly that. It needs a transformation function that takes a student and returns an age. So this is exactly what we just created here. Map will execute this function on each element of the array. So instead of having to write a for loop where we're going student by student by student, and we are accumulating, so the map function will call this transformation function for us and then spit an array of elements out at the end that did the transformation for each of the elements. Any questions so far? So we have a transformation function. The map function on students requires us to pass in as an argument a transformation function. So let's just do that. We can just take this function that we just wrote, pass it in as an argument, and we should have the same result. So we should have the same 3 numbers print out down here. And we do. So yeah, so hopefully not that complicated. Map is a function on an array. It's also on dictionaries and on other elements. So yeah, map is a way to transform a collection of something into a new collection of other things. So yeah, so we've seen map. So I just wanted to show you, so since this is a very cumbersome way to write this, let's create a new, let's do the same thing. We'll transform each element of students, and let's just get the names. But we'll do it not this this roundabout way by creating this function. Outside of this, outside of the map function, we'll pass in an anonymous function, which makes this a very this turns it into a one-liner. And once you're familiar with reading these, it makes it very quick to read and understand what it does. So yeah, we have our mapped student ages. Let's create a mapped student names array. So what's the type of these? Our name was of type string. Students dot map. So we have our transformation function, and then so instead of passing in a named function, so here we have a function that has a name. So the name of this function is student to age transformation. We're going to create a function that doesn't have a name. So it's an anonymous function or a lambda function. And we can do that by just, so we're just taking the curly brackets of the function, and we're taking what's inside. So we can, let's build it up. So we're going to take the entire contents of our student function, initial map function. Here we're not interested in the age, we're interested in the name. And then so this doesn't quite work yet, so there should be we would get here's the error. So for anonymous functions, there's this syntax that is maybe a little bit unfamiliar at first, where on the first line, right next to the curly bracket, opening curly bracket, we can give all the parameters that can be passed in. So student, so it's of type student. So this is the parameter that can be passed in, and then we give a return type. So the return type is string, and then we have to do this weird way where we're saying in. So this is the same thing. Well, I mean, conceptually, it's the same thing as what we did here with the named function. We have an anonymous function that takes a student as a parameter. Returns a string, and here we have the function body, a student that gets turned into a string. So again, so we don't have the name of the function. So so here we had the transformation function that was named. This function doesn't have a name. We're just using the curly brackets. We have this funny notation here where we're providing the parameter type and name, the return type, and then we have to have this keyword in here. And then apart from that, it's the same as a named function. So this still is not that much simpler. I'd say we now succeeded in making it a little bit less readable. So I find this and this much more readable than this. So this wouldn't be really that useful. Or I mean, it can be useful for sometimes, but we can make this more readable. So there's a couple of things that Swift doesn't need us to put here. So the first thing we don't need to do is the Swift compiler knows that this map function is going to operate on an array of students. So it knows that each of the elements in the student array is of type student. So we don't have to put the type here. So it can infer the type. Swift and the Swift compiler are very good at type inference. So type inference means you don't have to be explicit with what type something is supposed to be, because from the context it can be inferred. So type inference is when the type can be inferred from the context. So we don't need to have the type here. Also, when we just have one argument here, we don't need these. We don't need these here. We can get rid of that. We're just getting started. We can get rid of a bunch of other stuff here. So very nice. Here we from this it is very clear that our students array is supposed to be mapped into an array of strings. So Swift again can use type inference and figure out that the transformation function will return a string. So we don't need to put a return type. So Swift can still infer this. It doesn't stop there. We can make this simpler. Okay, we have a one-line function here. For one-line functions, we don't have to. Swift can infer again. It can use type. It can use type inference. It can know that whatever this expression here is actually supposed to return something. It's supposed to return a string. So we don't have to put the return keyword. So single line functions, anonymous functions that are single line don't have to have the keyword return there. So this is already looking slightly better, slightly reduced. I mean, I'd say it might look a little bit, so you kind of need to know what's happening here. So it becomes maybe, on the one hand, it becomes a little bit less obvious what it does because we don't have the return types and we don't have the type of the argument. But yeah, so there's less and less here that we have to write theoretically. So a couple of other things we can do here to make it simpler. I don't know if you remember, 2 weeks ago we talked about trailing closures. Who remembers what a trailing closure was? Or trailing function, you can also say. A trailing function, so if the little hint here is there's something special with the syntax if the function is the last argument, if we're passing in a function as an argument and it's the very last. So it's the trailing argument, so it's a trailing closure.
So we can get rid of the curly braces?
We can get rid of these braces here. So we can get rid of these braces. So it's a trailing closure, which means we don't have to have those. So more stuff to get rid of. Okay, so now it is going to go a little bit crazy. So we actually don't need this either. So there's a way that we can, so we have just one argument in this function. There's a way that we can, and we're using this argument in our processing here. So we're taking the argument and we're returning its string. In an anonymous function, there's a way to refer to each of the parameters that we're passing in. So right now we're just passing in one. If we were to pass in 3 things, there would be a way for us to refer to the first one, the second one, and the third one without giving it a name here. So let's see what that would look like. So we can get rid of this, and we can do $0 for the first argument. What do you guys think it would be if there were 3 arguments and we want the third argument? $2. Yes, so it's 0 indexed. The parameters are 0 indexed. And a little caveat here, this only works if you have a single line function. So it would get really confusing if you have a 15-line function and you're saying $2, $17. So it would get really confusing. So for single line anonymous functions, you have access to each of the parameters with this dollar and then number index. So let's turn this into one line. And now we have a very short, very terse way of saying, so we take the students array, map each element, and we're only interested in the name of this element. So map, so if you're familiar with seeing this, you can now just read students, map each element, take the name. So to me, this is a very readable way of processing arrays, and we don't have to do this iterating here. And it doesn't quite stop there. We can chain these. So let's do that next here. Also, there's one other thing we can get rid of. Swift knows that the transformation function is going to return strings, so we actually don't need the type for the array here either. So this is the absolute shortest we can write this this map function, and you actually see this a lot. So people who are familiar with using map, and there's a couple of other ones very similar like map. You'd see this a lot. So it's a good idea to try to wrap your head around it. So maybe let me just copy this. I'll go back. I'll take all of these steps back. Was that the last one? Oh, here we go. I'm gonna comment this out, and I'm gonna leave this here so at home you guys can follow the process by disassembling a function like this as well. Cool. So yeah, as I said, you can chain these operators as well, which is very nice. So you can do process after process after process. So the next one that we're going to see is I hope can I actually go here? Ah, it worked. Great. Okay, so let's see what else is on. So we're in the definition for the array here. So let's see. There's a lot here. So let's see what this map function looked like. We've seen this these square bracket what are these called? They're pointy brackets. I'm going to call them pointy brackets. We've seen these pointy brackets and this T. We've seen this before when we were looking. We were deriving from scratch what an optional was. So this was crucial in making the leap of creating an optional that I think we first looked at an optional of a string type, and this was crucial in making it so that we could use any kind of type inside our optional construct that we created. So so this means these pointy brackets are an indication that we're dealing with a concept called generics. So we don't have to write a map function for so the t shows up again at the end here, and also as the type of array that we have. So we don't have to write a map function that takes students and turns it into strings and integers and doubles and whatever we can think of. We just have to write one of these functions, and by making it generic, we don't have to write all of these extra functions. We'll see. I don't want you to get scared here right now. We haven't really talked about generics that much. We've seen it in optionals. We are seeing it here again. We're gonna actually tackle generics a little bit later in the course. So I just wanted to give you a little bit of a heads up. The map function deals with generics, so we don't have to have a map function for each return type that we could possibly think of. And then so this element is actually another generic keyword. So the way that I don't want to scroll up all the way right now, but so the way that the array is declared. So let's go back and see how an array is declared. So another way of declaring a student's an array of strings, I could do array of string. So this is another way of declaring an array of strings. So the element refers to the generic type inside the array. So we're dealing with two generic parameters here in this map function. So the type that's in the array and the type that we want to return. Okay, so so we have the map function. So I know what I'm looking for, so I can just search for it. So let's look at, where is it? Okay, let's look at sorted. So who here, and be honest, would be able to do sit down and write the quicksort algorithm? Who would be able to do that right now? I can't. So I kind of know it involves pivots and but yeah. So quicksort is a very quick way of sorting something. I can't derive that right now. And so yeah, other sorting algorithms. It would take me a while to figure out again how they work. So in your career as an iOS engineer, you will not have to write another sorting algorithm again. So on the array, there is a function that just returns a sorted array, and it does the same thing that we've kind of discussed before. It takes a function as an argument, and it returns a processed array for us. So this function is a little bit different. It takes two parameters as an argument. Where did we see this element before? What is the element generic keyword here? It referred to what? I mentioned it briefly a couple of minutes ago. So this is the type of the array of the elements inside the array. So this function that we're passing into the sorted function on the array takes two elements as two array elements as parameters, and and it returns a boolean. So the function that we're passing into the sorted method doesn't it's not a processing function. It is a comparison function. So the map function that we're passing into map was a function to process each element. Here we are passing a comparison function into the array, and what it does is it just takes two elements in the array, sees if one is larger or smaller, and returns a true or false. Is it larger or smaller? True or false. So kind of the same concept with a little twist on it. We're not processing each element of the array. We're going to go through the array. There's going to be some underlying algorithm that is going to do some comparison of array elements, and we just have to provide a function that defines what we want to compare. So the actual sorting algorithm, we don't have to worry about. We just have to say, how do we want this to be compared? We've already, we had an array of students. So let's comment this out for now. Let's just print out the array of students again. Students, there we go. So let's sort it by name and by age. So we can now, unsorted, so it's Axel, Bob, Alicia. So we will expect, if it's sorted alphabetically, starting with A, we would expect Alicia, Axel, Bob. And then for sorted by age, smallest to largest, we expect Alicia, also Alicia, Axel, Bob. So, okay, so let's change the ages. Let's make Bob 18. So then we'll expect Bob, Alicia, Axel. So I guess that one is, let's make it this way, so it's not just the reverse of the other one. Let's add a couple more names. So something with a, who can think of a name with a Z? Or Zach. Zach. Okay, how old is Zach? 80. Okay, so now we have something later on in the alphabet. Okay, so we have our student array. Before, so this is kind of awkward for printing it out. So each student has this like, okay, LLDB expression 5 student. So LLDB is the debugger, is the Swift debugger. And then I guess expression, so we're printing out some sort of an expression, and then student. So we don't want all this crap here. We want a nice way of when we're printing out an array of students, we want a nicer way to display this. So so if we have student conform to a custom string convertible, so it's a protocol that tells the console, if you're going to encounter something of this type, there's a special way to display this. So there's a custom string convertible protocol. We can just apply the fixit here for knowing how to implement it. So we can provide a description string. So the description string is then going to be printed instead of all this garbage down here. So description string, let's just have the name colon age. And we'll do it as a computed property. So return name colon age. So let's see what that looks like. So much nicer. Isn't that much nicer? Okay. So yeah, so the custom string convertible protocol with its description protocol makes it so when you're printing something out in the console, it's much nicer to read. Okay, little tangent here. Let's use the same thing that we did with map, where we had a function that we passed in that processed each element. Let's define a function that compares two elements, and then we use the sorted method on the array to have a sorted array of students. So I know that probably anonymous functions are still pretty confusing. So let's start by having a named function, and we'll deconstruct it until we are left with the absolute bare bones of it again. So again, so here we want. So let's do. So let's see what it wants. So students dot sorted. So it wants a function that takes 2 students and returns a Boolean. So a function that takes 2 students, returns a Boolean, and I'm going to call this a comparator function. So func compare 2 students, and then so student 1, student 2. Great. So compare 2 students, compares 2 students, returns a Boolean, whether or not it's it returns a Boolean whether or not it's one is smaller or larger than the other. So return compare 2 students. Let's do by name first. Compare 2 students by name. So return student 1 dot name. Strings can be compared just like integers with the smaller than and larger than symbols. So student 2 dot name, and it'll do the comparison for us. Okay, so let's pass this in. Let's declare a variable for the sorted students array. So var sorted students by name. Oh, and I guess so. We'll start with all of the bells and whistles, and then again we'll remove as we go. So sorted. Here we go. We'll see this in a second. The difference between sorted and sort. Yeah. So let's go. Just to make sure that we understand what this is doing, so we are declaring a new array of sorted students by name. We're generating this array by taking the array of students, calling a method on there that does the sorting for us, and all we need to do is pass in a function that compares to 2 students, whether or not one is smaller than or larger, and this function that we created happens to compare them by name. So let's see what happens. Okay, so by name, Alicia, Axel, Bob, Zach. So our original order was Axel, Bob, Alicia, Zach. Let's just mix it up a little bit. So you see that I'm not cheating here. So again, Alicia, Axel, Bob, Zach. Great. So we have our sorted by name compared to student by name. So let's create one that sorts by age also. Compared to students by age. So you're going to have to help me for this one. So how do we modify this method so it compares by age?
Just use the age.
Just use the age. It's that simple. Great. Okay, so let's pass that in, and the name of this method variable is going to be wrong. Let's just call it sorted students. Great. There you go. So we'll pass this new comparison function in, so we didn't have to change very much. And now Bob, Axel, Alicia, Zach are ordered by age. So super convenient. This would have taken me hours to derive the quicksort algorithm, and I probably would have made some mistakes. So super convenient. So yeah, so the sorted, there are 2 methods here, sort and sorted. So sort does in-place sorting, so it alters the array, and sorted returns a new array that is sorted. So most of the time you actually you probably want to return a new array. So then you still have access to the other one. Cool. So I said we wanted to take we wanted to make this a little bit we wanted to remove all the bells and whistles again to turn this into a quick one-liner, so I keep actually, I guess I can keep these functions, and we'll just turn this this here into this one-liner. So the first thing I can go, we don't need to define what kind of an array we have. The next thing we can do is, so instead of passing this in by name, let's pass in the function itself. So we'll turn this into an anonymous function. We are now missing something. So the anonymous function had this weird thing where, so we have to declare the parameters and the return type followed by in up here right after the curly bracket. So the return type is Boolean, so bool, and we have we can just take these parameters here, put them in here, and again, this does the exact same thing that we just had. It'll sort students with an anonymous function by looking at two students that we're passing in, returning whether or not one is smaller than the other, and yeah, the processing is here. Great. So lots of things we can remove here. First thing, let's turn this into a trailing closure. So again, there's just one function that is passed in, so we can get rid of everything except for the curly brackets. So that a little bit removed here. Next thing, we can remove the type of the students because it can be inferred. Again, Swift has type inference. Same with the return type, because we're processing ages, we're processing students. Sorted returns an array of students, and the comparison that sort uses returns a bool. We don't need to have the return type for this bool. We didn't need the return type. We didn't need to have the return keyword. And yeah, so now we can do this funky thing where right now we have named parameters. So we have student 1, student 2. Here we were referring to the parameter by its index. So we can do the same thing here. So we can get rid of all of this. And so student 1 would be the 0 index. So $0. Student 2 would be $1. And we can turn that into one line. So now we have a very quick one-liner for sorting an entire array. And we can, so right now, if I run this, it's sorted by age. Very quickly, I can turn this into sorting by name. So yeah, you don't have to write another sorting function again as an iOS engineer. You can just use the sorted method, and you just have to implement a comparison function. Cool. Any questions here? So it takes a little bit of time to read these. I think it's really worth it. It took me a while to be more comfortable with this. Yeah, so map is nice. Sorted is nice. There's a bunch of these. If you explore what the array, so if you option click, if you command click and jump to definition, you can kind of see what else the array has to offer. There's a bunch of neat stuff there. And yeah, so one thing that's a little bit more complicated. Maybe we'll get to this at the end of the class. So there's map, and then there's also flat map. We might see that one. So flat map can take arrays of arrays and turn them into just a single array. So it can do some processing and turn it flattens an array. So flat map exists also. If a processing result, so maybe one of the students doesn't have a name, and we don't want to drop that student from our processing, you have compact map. So compact map is the same as map, but it removes elements that resulted in nil when processing. So yeah, compact map. I use compact map a lot. Yeah, so map, compact map, sorted. Those are kind of your main go-to ones for these little neat methods. But yeah, so there's some other ones. Cool. Yeah, so we've seen, any questions here? Oh, another one is, I forget the actual name right now. So this one is on, yes, this one's on the dictionary, and on the name, I'll have to look it up. I'm blanking on the name right now. So you can combine, so you could combine an array into one number. So for example, there's one of these functions so for example, taking the average of an array, you would be able to do the same thing. It combines everything into one number. Or you can do some mapping of a dictionary, and it turns it into a new dictionary. So I'm blanking on the name there right now. Maybe something for you to explore. Yes?
I think it's reduce.
Reduce, thank you so much, yes. So you have your functional programming terms down.
Yeah,
Very
I've
good.
taken programming languages.
Great. Yeah, so reduce, very powerful. I find it slightly more complicated, but yeah, so reduce is also a great one. So I'll just write it here for you to maybe take a look at. So take a look at reduce. Thank you so much. Cool. So yeah, we've seen lots of stuff on arrays now. We haven't really seen dictionaries, and we're going to take a quick look at what a dictionary is, and then we're going to actually we're also going to take a look at what a set is. So since the set is very similar to the array, let's start with a set. Just hearing the word set, what do you guys think the difference is between a set and an array?
Is it a set of arrays?
A set of arrays could also exist, but what is a set? Yes, so it's the mathematical definition, very similar. Yes.
Isn't it like a dictionary that only holds the count or value?
So I think you're on the right track. You don't have it quite yet. Yeah. Unique elements. Very good. So it's pretty much an array, but each element just occurs once. So if I were to create, maybe there's another person with the name Axel, and that person is 55. Depending on how I define set inclusion, if I just look at the name, we would only have one of these. If I were to look at both variables, it would be both people would be allowed in the set. So yeah, let's take a look at the set. Yeah, first of all, let's see if we can let's explore from the ground up. Set of students. Let's see how I would declare a set of students. So set, that makes sense so far. It doesn't have this syntactic, so there's syntactic sugar for syntactic sugar. Have I mentioned that word before? Syntactic sugar is like when there's a feature of the language that makes it so I don't have to write as much. There's like a shortcut for writing something. So like the question mark is syntactic sugar for unwrapping the enum, the optional enums, or removing, not having type inference, I guess, is syntactic sugar. Not having to declare an array like this. So this theoretically would be an array of students with a generic notation. So not having to declare it like this, but being able to do this. So this declares an array of students. So this is syntactic sugar. So the set doesn't have syntactic sugar, so we have to use the generic notation. So let's do a set of students. We have our first error here. So student does not conform to protocol hashable. What do you guys think that means? So what does it mean to hash something? Who has heard the word hashing before? Raise your hands. Oh, okay. So where have you heard hashing? Where have you heard the word hashing before in other parts of your life?
in cryptography
Cryptography, yes. Okay, how do you use hashing there?
for either checksum or force digital signatures.
Very good. Yes. Another way. So to make sure that if I'm installing something, a program, it can be signed, or so there can be a checksum that I can look up before I install this program. Is this the program? Has it been altered? So the entire program was turned into a very small, like string of characters. It's hash, and I can say very quickly there's a way I can compute this hash. From the entire program, and I can see if it was altered. So if this doesn't match the hash that is published for this version, then someone might have installed a virus in this program. So yeah, hashing is used there. You take an entire program, you turn it into a small little number. So in storing passwords, are you supposed to store passwords in plain text in your databases? No. Do not store people's password in databases. I'm sure you know. So one way of storing passwords, you don't actually need to store the password in a database. You just need to be able to have a way to turn a password into some version of the password where you have a one-way method of turning it into a hash. You can store this hash, but it's very hard to revert this process. So instead of storing the plain text password, the user says, this is my password. You turn it into a hash, you store the hash. If they're trying to authenticate, they give you their password, you turn it into the same hash, you compare if it's the same. If they match, you let the user in. So hashing is a way to turn something hopefully into something else that is unique. So the better hashing algorithms avoid collisions. Collisions is when two different things are going to hash into the same value. Whenever you turn something big into something small, there's a pretty good chance that there's multiple ways of doing this. But yeah, so if you have a good hashing algorithm, it avoids collision. But yeah, so hashing is there to, being able to turn a big object into hopefully a unique thing that is much smaller or can be referenced easily. So a hash is used to, what do you guys think a hash is used inside a set? How do you think the Swift set, why do you think students has to be hashable? So if you think about what a set is, yes?
It's basically either index or location by accessing which you could actually get your value.
So it's not to access the value. For a dictionary, we would just have to access it.
Yes.
So for a dictionary, the hash would be to access the value. For a set, there's another part there. Who can think of it? Yes.
Oh, like a unique key.
Yes, a unique key. So we need to make sure that all the elements in our set we need a way to compare them. So it's also used for that. But yeah, but also for retrieving the element. Yes.
And for almost instantaneous access to them.
Yes, that as well.
Element.
Yeah. Very good. Okay, so yeah, so just by trying to instantiate a set here, we've learned a bunch about how it works or what might be happening in the background. So our type student has to conform to the hashable protocol. So let's see what we have to do there to do that. So let's add the hashable conformance. Let's explore what the hashable protocol looks like. So we have a protocol hashable. So the protocol hashable means that it also has to implement the equatable protocol. So hashable is on top of the equatable protocol. What do you guys think the equatable protocol is there for? Equatable, just from the name? Are two things equal? Yes. So we can look there as well. So equatable, we have a function here for being able to, so left-hand side, right-hand side, we have a comparison function, and we have the equality over operator overwritten here. So yeah, equatable, the equatable protocol the only thing that is that we have to define there is, are these two equal? And then, so the hashable, so actually I think you might be right. So the hash is just used for storing and retrieving, and the equatable is there to make sure that they're equal. So you were totally right. Great. So we have our where did it go? Okay. So hashable. So hashable has to be. We have to also implement the equatable protocol. So we have to make sure that we can compare two elements, and then so we see hash value here. So this is actually the old way of doing this. It is so it's deprecated. This was the old way of creating hashable conformance. The new thing we have to do is we have to implement this method. So this is conceptually slightly easier to understand. So maybe actually let's implement it the deprecated way first, because I find it slightly easier to understand, and then let's implement it the new way. So this is fairly recent, within the past year. Okay, so our student has to implement hashable, and as it implements hashable, it also has to implement equatable. So just saying this is not going to give us conformance, but the error is not showing up. That is going to hopefully help us. Oh, we're not being helped. Oh, oh, this actually, did this work? Oh, I think by description string, this should not have worked. Ah, there we go. Okay, so description string for some reason gives us, let's see. This should not have been enough. I am confused. They must have changed something. This used to be, we used to have to implement this. I am baffled. This is, well, let's see if this works. We definitely used to have to do a little bit more here. So let's see if it does the right thing. If it doesn't do the right thing, we implement the thing that we have to implement. But yeah, so far it seems like it's supposed to work. So we just have to say it's hashable. We'll trust it, actually, let's implement what we normally would have to implement. So for hashable, we saw we have to do hash value, and it's of type int. A good way to so we have to now decide how do we create our hash value. So ideally, in a way that it turns this into a unique item. So if we want to take both of these into consideration, we could come up with a hashing algorithm that turns this into one thing, or we could cheat. Let's say we only care about name. We can just return the hash value for the string. So return name dot hash value. Okay, so this would give us. Most of the time, this is not going to work. I'm actually baffled that this works right now. So you will normally have to implement your hashable and your equatable conformance. So we're going through these steps. So yeah, this was the deprecated way. It's just a way to turn the student into a hash value. And then yeah, so this was the old way of doing it. Let's just go to the function that we need to implement now. So old way, and then the new way, we have to implement this method. And the same thing, we can cheat here. We can take just, so name dot hash into hasher. Okay, so we're cheating again. We're just taking the name and we're turning it into the hashable protocol. So there's a couple of things here that we haven't seen in this method that you'll actually see very seldomly in Swift. We have this in-out keyword, and then we have this this ampersand in front of hasher. So in-out means that we're passing a pointer, pretty much. We're passing a pointer in your own code. I have not written a single in-out function in my I don't how long have I written iOS code now? 6-7 years or whatever. I've never written an in-out method. So somehow this was necessary for how they. I don't know why they needed to do this, but yeah. So this is our hashable implementation. Let's look at how we have to implement the equatable method. So this one is actually slightly more interesting. So because we'll learn something about creating our own operators. So so what does this do? Okay, so self, we have I think we have to do this. Here we go. So what are we doing here? We are creating so func and then this operator here means we're creating our equality. We're creating an equality operator. So you can just define what this means. You can also create. You could potentially define your own multiplication operator. Other way, you can come up with your own operators. So there's a couple of libraries that create completely new operators that they define what it means. Very interesting. So maybe I can a little bit later. Maybe I'll show you one of the languages that does this. So when it was very hard to work with JSON in Swift, someone created an operator for unwrapping JSON objects. So they just created their own operator. Very interesting. But yeah, so we are defining our equality operator here. And how does this work? So we're going to compare two students. This is left-hand side and right-hand side. And again, we're returning a bool. So return left-hand side equal right-hand side. So what are we comparing? It now depends, again, how do we define equality? So in our hash value, we've defined equality by just the name. We've made that design decision. Ideally, we would probably also take into consideration the age. But here we are just .name and .age. We could just add an additional comparison here for age. Oh, there we go. Name, age. So now it compares both of them, but now our implementation of the hash value doesn't match. So you kind of want to keep these in sync. So even though this is more correct, well, this could be potentially more correct for comparing two students.